So just want to help you if you're struggling with any of these questions, right? Watch this video. I'll also link so you could skip around to go over each question, right? If you want to go over number one, that's what we'll start with. So looking at number one, what is the solution to the system of equations below? One, we learned three ways to solve systems. So the first way would be to graph, right? We could graph these. Two, elimination. And three would be substitution. So all three of these are options when we're looking at this one. I might start by, let's just trying to graph these. And I see one of them is already in y equals mx plus b form. So this one looks good. But let's solve this one for y equals mx plus b. So we got 3y minus 6x equals 24. So first thing I'm going to do is I'm going to add 6x to both sides. I want to get y by itself. So we get 3y equals 6x plus 24. Now I could have wrote that as 24 plus 6x, but it's always helpful to get y equals mx plus b. So having that x first is really helpful. All right, 3 times y, I got to divide all these terms by 3. So y equals 6 divided by 3 is 2x. 24 divided by 3 is 8. So 2x plus 8. This is the equation in y equals mx plus b form. And I noticed something kind of weird. It is the exact same equation as the first one. So it's going to be the exact same line. If I graph these, it's going to be 2x plus 8. So it's going to look like this for the blue line. And then the green line is also 2x plus 8. So they're going to be right on top of each other. And that means we have all these points as solutions. There's infinite solutions because it goes on forever. So that's how you could do it solving for y equals mx plus b. The other option, right, would be to use that graphing calculator if you have trouble solving. And we could just graph these two. So we had 2x plus 8 is my first equation. Then I'm going to hit tab for a new equation. I'm going to make this a relation because it was 3y minus 6x equals 24. And that was not solved, so it's a relation. But we see we get the exact same line. So this is infinitely many solutions. Kind of a weird one. The other one that could be weird is if we had two lines that were parallel, they would never intersect, so that would be no solutions. So those are the weird ones. When it just crosses in one point, it's just going to be a point like 2, 8, or 0, 0. But this first one was infinite solutions because it was the exact same line. Number 2, which equations will yield the same solutions as the system below? So the first thing I want to do here is find out what is the solution to this system of equations. And again, right, I got to do it for 1, 2, 3, 4, 5 different times, right? That's 5 systems to solve. Quickest way to do this is going to use that graphing calculator and graph our relation. So let's go over how we could do this. The x minus y equals 8, y plus 5x equals 10. Let's find the solution here. Looking at these two, I'm going to go to a new graph and I'm going to do a relation because they were not solved for y. So this is going to be the quickest way to do it. Equals 8 was the first equation. I'm going to hit tab for my second equation. Y plus 5x equals 10. And now to find the solution, I'm just going to analyze this graph. Menu, analyze graph, 6 or 4 for intersection. I got to go left, right. It is 3, negative 5. So the solution for this system was 3, negative 5. So I want to find which one is the same as 3, negative 5. Which of these systems is going to be the same? So I'm going to check number 1 first. X minus y equals 8. 2y plus 10x equals 10. Let's check this one. I'm going to do a new graph. I want to have the same solution. So I need 3, negative 5. Again, it's going to be a relation. Just going through these quick. X minus y equals 8. Graph it. Tab for a new line. It's already a relation. 2y plus 10x equals 10. Well, that looks close. Let's see. Menu, analyze graph, intersection. I was looking for 3, negative 5. This is not 3, negative 5, right? Those are decimals. It's close, but not 3, negative 5. They made that one close. So if you were just trying to guess, it looked about the same. But if you actually use the calculator, it's 2.7 and negative 5.83. So this one was not right, negative 2.7. right? It was not the same as 3. So number 1 is wrong. Let's try number 2. 3x minus 3y equals 24. 2y plus 10x equals 20. I'm going to graph these two. Again, I'm going to use that relation and check number 2. 3x minus 3y equals 24. Make sure you type it right. Tab. Then we got 2y plus 10x equals 20. Again, looks close. Let's check it. Menu, analyze graph, intersection, left, right. 3, -5. That one is the same. So this one's going to be the correct answer. And to save time on this video, 3, -5. I'm not going to check the other two, but if I was on a test or quiz, I would double check the other two just to make sure. But number 2 is the correct one for this one. So let's look at number 3. Jake purchased some Coca-Colas here for $2.25 each and Doritos D for $1.50 each. So right away, I see these are both talking about money. Doritos $1.50 each. He purchased 11 items and spent $20 total. So I'm going to make my money equation first here. So it's going to be $2.25 times our Coke plus Doritos are $1.50 each. And total money we spent is 20.25. So I'm going to look for that equation here. So here looks right, 220. Oh, that's 225D. So this one's actually wrong. This one's 225D again equals 11. That one's wrong. 225C plus 150D equals 11. So that one's wrong. This is the only one with that money equation correct. So it's going to be number 4. But just to check the other part, if we purchased 11 items total, we have our Coke, how many ever we got with those, plus our Doritos, got to equal 11, which is also this equation here. Because if I bought 10 Doritos, I would have 1 Coke. So Coke plus Doritos equals 11, total items bought. So 4 is the correct answer on number 3. All right, so looking at number 4, we got a solution of a system of inequalities. One thing that's always helpful when looking at inequalities or any graph, we want to get y by itself. So first thing I'm going to do is I'm going to divide this equation, both sides by 2. So we get y is greater than or equal to 6 divided by 2 is 3x. -4 divided by 2 is -2. So I need y greater than -2. So I'm going to look for y-intercepts at -2. There's one. That's got a y-intercept of -2. And it's got to be above that line because it's greater than or equal to this. So right away, I look greater than. This one's not above that line. It's below it. So that one's not correct. This one, I look, oh, the y-intercept's -2 right here. And it's above that line. So this one could be right. Number 3 still in the running. This one, we got -2 as the y-intercept, but we're below that line. So it's not this one. And this one's -2, and it's above that line. So it's either 3 or 4. Let's check the other line. Right now it's y -2, so I'm going to add 2 to both sides. Y is less than -x plus 2. So we want to be below, and also it's a less than, not less than or equal to sign, so this should be dotted. So this line should be dotted because it's not equal to this one. So right away, I see this is the only one left with a dotted answer, so it's going to be number 4. But just to check it, y is less than x plus -x plus 2, so the y-intercept is there at +2, and it's below that line, so that's right. So number 4 was the correct answer. So I just wanted to check both, get them in y equals mx plus b. All right, so what point is in the solution set below? We're just going to graph these points, and remember the solution set for a system of inequalities is where both of them cross. So anything in here is going to be in this solution set. And remember, if it's on a dotted line, it's not in the solution set. If it's on a solid line, it is in the solution set. So let's check. 2, 0, right? 1, 2, 0. That would be on the dotted line there. So it is not in the solution set because it is on the dotted line. And remember, it's not equal to that line. 0, 0, definitely not in it. That's not in anything, so that's easy. 4, 2, right? 1, 2, 3, 4, up 1, 2. Oh, that's definitely in both. That one looks good. And then if I go 1, 3, 1, 2, 3, this one is in one of the solutions, but not in both, right? It's only above that dotted line. It's not in both. Sorry about that. That's going to be annoying in the video. All right, so correct answer is 4-2. Not that bad. All right, let's say 3 friends go to a restaurant and order 2 sushi rolls and 3 teas. So we go to a restaurant, we got 3 sushi rolls, 3 teas, and their bill totaled $31. So let's do an equation based on this first situation. 3 friends, I don't need the 3 there. We just need 2 sushi rolls. So I'm going to go 2s plus 3 t's is equal to $31. Not an inequality here. It's just equal to that much. Later that day, 6 friends went to the same restaurant and they ordered 7 sushi rolls. So this equation, we got 7 sushi rolls and 1 tea each. Their bill totaled $99. Ooh, it's a lot. So 7 sushi rolls for this one, 7s, plus 1 tea each. So 6 friends got 1 tea each. So this is 6 tea. We just got to read carefully there. And it totals $99.50. Now there's a couple ways to solve a system of equations, right? Algebraically. So we can't graph this one. We got to use algebra. It says algebra right here. So we could use elimination or substitution. I always like to use elimination. I think it's easier. So I'm going to try to eliminate something. So I look at what could I eliminate? So I have 2s, 7s. I can't really multiply by 2 to get to 7 without doing decimals. I could multiply them both by something, but that seems like too much work. So let's look at the t's. 3t and 6t. Ooh, that's pretty close. I just got to multiply 3 by 2. That would give me 6. But I want it to cancel out. So I need it to be a negative 6. So I'm going to multiply this top equation by negative, so it cancels out. And then 3 times 2 would be 6. So I'm going to multiply this whole top equation and get negative 4, because 2 times 2, negative 2 times 2 is 4, s, minus 2 times 3 is 6, t, equals negative, because negative times positive here, 31 times 2 is 62. So I just changed that first equation by multiplying it by negative 2. So that's all I did right there. Let me just draw a little line here. So now I have that green equation and my new black equation. I'm just going to add them together. That line. And the t's are going to cancel out here. So 7s minus 4s is 3s equals 6t minus 6t. That cancels out. 99.50 minus 62. I'm going to use my calculator. 99.50 minus, it was 62. 37.50. So 37.50. Almost there. It's 3 times s. I'm going to divide by 3 on both sides. So s equals 37.50 divided by 3. Let's do it. 37.50 divided by 3. Probably going to be a decimal. 12.5. So a sushi roll costs $12.50. So we just figured out the sushi roll, $12.50. Now, determine the price of 1 sushi roll. That's all we had to do for this one. Determine the price of 1 sushi roll. I just went back and reread the question. But if I wanted to find the price of a tea, I could go back and plug in my sushi roll into like here and do 2 times $12.50, which is $25 plus 3t equals 31. I'll just show you it. So if you had to do it, you could. I'll go over here. So if we did 2 times $12.50 plus 3t equals $31. I'm just plugging it into the top equation in blue. 2 times $12.50 is $25 plus 3t equals 31. Subtract 25 by both sides. 31 minus 25 is 6. Divide by 3 on both sides. So t costs $2 each. So the t costs $2 each. So you could figure out the t if they asked for it, but they just said determine the price of one sushi roll, and we did that. All right, so if we want to graph a system of inequalities graphically, again, to graph this, we want to get y by itself first. So I'm going to do this one over here. I'm going to add 4 to both sides. So y is greater than or equal to negative 2x plus 4. And I'm going to graph this on my axis here. So positive 4 is my y-intercept. We always start with that y-intercept. So positive 4. Be easier to use my mouse. 1, 2, 3, 4. Here's my first point. And then my slope is negative 2, or negative 2 over 1 if we make it a fraction. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. I'm just going to put all these points on here. Down 2, right 1. So I could go up to left 1, and that would still be negative. Up to left 1, up to left 1. And since it was greater than or equal to, we could do a solid line here. We would want to do a solid line because it could be equal to this line. And greater than means above. So I'm going to shade above it. So it's got to be greater than or above this line. Now I'm going to graph the other one. I'll do that one in red. We'll keep the Christmas color theme going. So 2y, I'm going to add 6x to both sides. So is less than 4 plus 6x, or I could just write the 6x first to keep it in y equals mx plus b. So 2y is less than 6x plus 4. I'm going to divide both sides by 2. Make sure you divide all the terms by 2. And we're left with y is less than 3x, because 6 divided by 2 is 3, plus 2. So here's my other equation. So my y-intercept is at positive 2. Positive 2. And then my slope is 3, or 3 over 1. So I'm going to go up 3, right 1. 1, 2, 3, right 1. Up 1, 2, 3, right 1. Now it helps to put a lot of dots. I could go down 3, left 1 as well. Down 1, 2, 3, left 1. Down 1, 2, 3, left 1. And this one is just less than. So I'm going to do a dotted line because it can't be equal to this line. It's got to be less than this line or below it. So I'm going to shade below this red line. So my solution is where my red and green shading crosses. So anywhere in here is my solution, where the red and green cross. So this is my solution. So we're going to label that solution S. So this is my solution. I also highlighted it. Determine 3, 3 if that's in the solution set. Let's look at 3, 3. If I go over here, I go right 1, 2, 3, up 1, 2, 3. That would be right here. That is in the solution set. Yes. It's in both of those solution sets. The red equation less than 3x plus 2, it's less than that line, and it's greater than the negative 2x plus 4 line. So that is in the solution set. You could also plug that into both equations, right? A 3 in for the x and a 3 in for the y up here. And you would get 3 is less than 3 times 3 is 9 plus 2 is 11. So 3 is less than 11. So it's true for this equation. 3 is less than 11. And if I plug in 3, 3 to that green equation, 3 is greater than or equal to negative 2 times 3 is negative 6. I plugged in a 3 for the x here. So that's negative 6 plus 4 is negative 2. So 3 is also greater than negative 2. So it's in both solutions. So that's another way to check if you were confused graphically. All right, last question. We're going to do just our last one here, which is the part 2. And it's how to find, right, a system of equations graphically with a word problem. So let's say 2 families went ice skating. The Branch family paid